All right, everybody, welcome to Lab 3. So during this lab, we're going to be going over recursion using the ACR function. So um, in this lab, you get two things. You get the PDF, which walks you through what the output of the ACR function should look like, so what your program should look like when it runs, as well as the definition of the ACR function, some pseudocode to help you write that, as well as some guidelines on how you should be processing user input, or I should say, what kind of user input should be allowed. So for this lab, we are going to be doing some checking of the user input. So for the ACR function, there's no negative integers and that kind of thing. We'll also be doing a little bit of controls where you'll be asked to enter integers separated by spaces as well as letters. So like there's a queue to quit, but all that's in the PDF, and I'll go over that towards a little towards the end of the video. So to start out with, as I mentioned, there's some Java code included as well as a PDF. But first things first, let's start a new project. So as always, I'm just going to name it Lab 3, leave it all as default, finish. I'm going to make a new class, and this is the code that's provided. So this one is called ACR function. Let's just finish that. And I'm just going to copy the code over from the document that was given. So this is given to you. And here we also see that there's a comment where this is where our code's going to go. As I said, the PDF outlines some pseudocode to help you fill this in. It shouldn't be too difficult to fill this in. Next, we make the main function. So this is just the function itself, but we actually need the app to drive this function. So, something to call this and do user input and all that kind of thing. It's clean to have that in separate files. So we're going to make that right now. That's not provided. So we'll have to go to new class. And for this one, we do want the main. So we want the main method included in this one. So I'll name it first. I'll name it ACR app. And I'll check this little box so it has the main function there. So I'll finish it up, and we see it auto-generates with the main function. So once that's kind of squared away, your program is kind of set up. You can kind of start coding here. First thing you'd want to do is user input right here, and I'll go over that in just a second. And then the next thing you'd want to do is actually call your ACR function. So once you fill all this in, I suppose you'd want to fill that in first. But once you fill all this in, you actually need to, you want to be able to use this function in the main function, or you want to be able to use all of these methods from within this main Java program. So to do that, we can quick scan through this class, and we notice that none of these methods are static. So static means you don't need an instance of that method, or an instance of this class, I should say. So we see that none of these methods are static. We have a couple, most of them are public. We have a couple private attributes here and there, but none of them are static, which means we'll have to have an instance of this class in order to use any of these methods. So I won't be able to just say like ACR function dot ACR. I need to make an instance. So that should be one of the first things you do, maybe after you get the user input. So we would want to make an instance of the ACR function. We can do that just like we make any other variable. We would specify the type. In this case, it's just this class type. I give it a name. I'll call it A for now. I suggest you use maybe a little more descriptive variable name, maybe something like ACR instance. That's nice. And then we want to make a new ACR function instance. And we see the class doesn't take any arguments. We can see that actually, it doesn't, there's no constructor specified, so it's going to have no arguments. Make sure there's a semicolon at the end. And this is our instance of the ACR method. So if I want to use this, let's say I want to call this ACR function, which is the main function that we're interested in for this lab, I would say my ACR instance dot, and then I can see I get a whole bunch of options. Top one is ACR. Nice. And then we'd want a value of m and n. Now, these are just kind of variables that are specific to the ACR function. For the case of this lab, we don't really need to know what they mean or what they do, but they are specified in the PDF as far as what values they should be, some minimum values, things like that. So these are what you're getting from the user input as a space separated integers. So actually, a couple of recommendations I have on that. So you'd of course need to make your scanner as you've done in other labs. My recommendation for getting a space delimited list of integers is first, I would recommend making your or getting the user input in as a string. So you should have done that in previous labs, but if you, assuming you had your instance of the scanner, you could do something like next line, something like this, where you just get an entire line from the user. And then what you can do is use the split function to split it on spaces. So then you can say something like line.split, and we can split it using a space. So there's a space in between here. And what this is going to do is this is going to give me a list of strings. So this would be, you know, something along these lines. Actually, this goes over here. So it's going to give me a list of strings back. And so if I, for example, if I entered 3 space 4 space 5 in this next line right here. So let's say this next line got 3 space 4 space 5 from me. After this line, this input list would be 3 elements long and would have the string 3, the string 4, and the string 5 in it. So at this point, you can kind of do what you want with it. You can do some input validation, that kind of thing. So the PDF mentions that you should be able to enter Q to quit. So like an example of that is you can say if input list 0 equals Q, something like this. So you can check on those inputs and see and do your tests that way. Another very helpful function is going to be the parse int. So if you do integer.parse int, we can see that this method is going to take a string and returns an integer. So this is how I might take this list of strings and parse out those 2 integers. So if I wanted the first element of this list and parse it as an integer, I can do something like input list 0, and this would return an integer. So I can say int m equals, and there's my m. That's going to be the first element. So even if I entered 3 elements, I could only take the first 2, but this is some kind of input validation you can do. And you might have to Google this, but I believe this will throw a value exception or some kind of exception if, oh, there we go, throws number format exception if it's not a integer. So maybe that's a way you can try to test if the input is an integer or not, or you can look back at your last lab and see if that first character is an integer, or I'm sure there's a Java method for it to check if that string is an integer. Do some Googling, do some research. I'm sure you'll find something that that can do this nicely. So now more about the actual ACR function. So this is how we would call that function, but the PDF mentions that it wants you to trace through it. So this is kind of the output that it's looking for. We see that every time we enter the ACR method, so entering is really just going to be right at the start of the method. So here is the enter, and then exiting is down here, obviously just before the return. Here is the exit. So this is kind of where you'd be wanting to put these print statements. We say leave method ACR, and we have enter method ACR, and you'd want to be printing out these m and n values as you do that. But one more thing to note is every time we kind of nest down into, it's a recursive function, so every time it calls itself again, we have more tabs that are going before the enter method. So before you actually do any printing right here, so this would be, you know, printing your enter or, you know, something along these lines. You actually want to be able to print all these spaces that go before that. So you actually have a function if you look through here, or a method. You have a method right here called print spaces, and if we take a quick look at that, we see it takes the number of spaces, which we can see is defined right up here as this member, so this private member. For every number of spaces, it's going to just print 1 space. So if spaces is equal to 10, it'll print out 10 spaces. And we also note that this is system.out.print. This is not print line, so that means this is all going to print on the same line. So this is going to print if spaces was 10, this would print 10 consecutive spaces. So this is a function that you'd probably want to call before you print this enter. And you can either do print spaces, or you can also do this dot print spaces. If you're feeling real explicit, you can do that. But of course, if you never change the value of spaces, it will always print 0 spaces. So think about where you would want to change the value of spaces. Clearly, on the first iteration, we start with 0 spaces, but on the second iteration, we have more. On the third iteration, we have more. And also keep in mind that those spaces are going to both increase as you're going down deeper into the recursion, but they're also going to decrease as we kind of leave those levels of recursion. So here's an example right here where we enter the method and then we leave the method, and those are all on the same line. So after entering, we exit. There's no additional spaces here. So try to think about where we would want to increase the number of spaces for this Acker object, and think about where we'd want to decrease them. All right, that should be it. Good luck with that, everybody.